Welcome. In our last section here, we talk about methods of data collection, and there are essentially two methods, and the one that is chosen would be based on the research question. So an observational study is a study in which a researcher measures and observes the variables of interest without changing the existing conditions. So essentially, it's the researcher just sitting back and watching the world around them to try to draw conclusions. And I'm going to just jump already down to number 1 here. This is how we would start to investigate the relationship between chronic lung disease and vaping. So essentially, researchers are just gathering data as time goes by, trying to see what relationship they're seeing between those that develop chronic lung disease and their use of vaping. So this would be an example of when an if I spell it correctly, observational study would be appropriate. And we'll see why what would not be appropriate would be to conduct a designed experiment. So let's look at designed experiment. In a designed experiment, a researcher assigns a treatment and observes the response. Sometimes we'll have a control group. This is a group receiving no treatment or receiving a placebo. So you probably heard the word placebo before. It just means an innocuous treatment, so something that literally does nothing. You'll hear it referred to as a sugar pill sometimes. So we would have these two groups and we would compare the effectiveness of the treatment. And generally, a designed experiment is needed to establish a causal relationship between two variables. So the problem with doing an experiment for my number 1 example here, if you wanted to see if vaping is contributing to the development of chronic lung disease, you would not want to make as a treatment, you would not want to recruit people and force them to vape just to see if they get lung disease. That would not be very ethical. And so a designed experiment here would not make sense. It may be a helpful thing to see if vaping is causing chronic lung disease, but ethically speaking, we don't do that. We just have to wait and see and gather data as people unfortunately develop chronic lung disease, and we try to see how that is linked to possible vaping. All right, so let's look at number 2, though, collecting data on the use of blue light blocking filters in the prevention of digital eye strain. So this is certainly an example where a designed experiment can be done, has been done, because you could recruit people to be in a study, perhaps people that have experienced digital eye strain, and have them try out glasses with blue light blocking filters as opposed to those without, and see how it contributes to their digital eye strain to find out if they are helpful. So that's a designed experiment. And then lastly, number 3, collecting data on the relationship between social media exposure and mental health in teens. So this again would be our observational study. And you can read all about studies in this area, but they would not do an experiment here. They would not make people watch social media or be on social media just to see if it develops mental health issues. They develop mental health issues. So you would not ethically be able to do an experiment to study the connection here. So just an observational study, just watching the world around us and collecting data. All right, so in either case, observational study or designed experiment, we're looking at 2 variables. So one is called the independent variable. And in algebra, you would be familiar with calling that the x variable. In statistics, it's also called the explanatory variable. So in a designed experiment, x, the independent variable, is the one that is manipulated by the researcher, such as having somebody wear regular glasses or blue light blocking glasses. And in observational study, it's the variable observed by the researcher that takes on different values, like their teen social media exposure. And then the dependent variable, so dependent variable, we call that Y, or the response variable, and that's the one that we look at to see if there is a change based on the explanatory variable. So social media exposure can that be used to explain mental health in teens, the response variable. All right, one more example here just for practice. So researchers want to explore whether high concentrations of vehicle exhaust impact incidence of asthma in children. So they want to see if vehicle exhaust exposure, I am having trouble spelling things today, exhaust exposure can explain the incidence of asthma in children. I'll just write asthma here for short. So asthma in children. So then it says confounding occurs. So it refers to the possibility that changes seen in the response variable, so asthma development in children, are at least possibly due to uncontrolled variables in the study. So if we're wondering if asthma, what contributes to that is vehicle exhaust, perhaps another factor involved may be those children that are living with a high concentration of vehicle exhaust, perhaps they also live in an area with high industrial pollution. So if they're exposed to both vehicle exhaust in high concentrations and industrial pollution in high concentrations, how are we going to distinguish which one may be leading to a higher incidence of asthma? So that's the deal with confounding. And so it's something that researchers always have to consider when they're doing their research. And it can be difficult to isolate if just one thing alone is contributing to another. Often it's more complicated. So we'll end here with just a kind of a silly example of this idea of cause and effect not being the same thing as two variables being related or correlated. So here's my headline. Shark attacks are linked to ice cream. Data shows that when sales of ice cream rise, so do the number of shark attacks. So to stay safe from sharks, don't eat that ice cream. So the reality here, this graph is true. It turns out that as more ice cream is sold in this country, the number of shark attacks also tend to increase. So the two variables are correlated. So they are kind of changing in the same way. The problem here is that definitely eat your ice cream if you like ice cream. It has nothing to do with the sharks attacking. So this idea of a lurking variables are a common problem in observational studies when an apparent association between two variables is really just a common response to some third unseen variable. So the idea here is throughout May, June, July, these are summer months, right? It's getting warmer. Well, it's getting into summer. So as we go into summer and it gets warmer, more people are eating ice cream and more people would be in the water. And if you've got more people swimming, there would definitely be more shark attacks because there's more people there. So it's not that the ice cream is causing the shark attacks, that factor that's contributing to both. I'll just write summer or hot weather. It's the hot weather that's causing ice cream sales to go up and more people swimming, leading to a higher number of shark attacks. So again, kind of a silly example just to sort of illustrate that just because two things are correlated, it doesn't necessarily mean that one is causing the other. All right, and that ends our introduction to statistics. And next we'll go on to learning how to gather data and summarize it and graph it.